Now I am continuing the previous lecture. Now second example of Laplace transformation. To find the Laplace transformation of function, to find Laplace of t into e to the power minus t into sin 2t, sin 2t. Solution of this problem is, first I have write, we can write L t into e to the power minus t into sin 2t. First I have left by a partial of Laplace transformation. First step to solve, step number first, I have solved we have L sin 2t. Now this is the basic formula of Laplace. You note down this. This is equal to a means 2 to the power 2 total upon s square into a square means 2 square 4. Now you put the value of e to the power 2, e to the power t. Now second step is step number second. Now L e to the power minus t into sin 2t. We know that if L e to the power minus at into ft is equal to f s plus a. Now this property is used for this L e to the power minus t into sin 2t is equal to 2 total upon s plus 1 to the power 2 plus 4. You can write this L e to the power minus t into sin 2t is equal to 2 total upon s plus 1 to the power 2 plus 4. Now the step second, third, I have put in the value of t. Now L t into e to the power minus t into sin 2t. You have also find the value of e to the power minus t into sin 2t. Now you can apply the conclusion. We know L t to the power n ft is equal to minus 1 to the power n d to the power n upon ds to the power n into fs. Now the conclusion used for this, so you put now L t into e to the power minus t into sin 2t. You can write this minus 1 to the power 1 d upon ds. Now putting the value of this 2 total upon s plus 1 to the power 2 plus 4. Now solve this. Now solve this differential. You can write this minus 1 into numerator differential. This means is coming to upper. So I have solved for this is very simply this. First I have solved for this. Now I have putting to first of this is minus 2 into power of minus 1 minus 1 into for this s plus 1 to the power 2 plus 4 to the power minus minus 2 into in differential of inside of this means 2s plus 1. Now we put this 2 to the 4 1 minus 1 into minus 1 plus this means 4 s plus 1 total upon s plus 1 to the power 2 plus 4 to the whole power 2. Now you simply write L t into e to the power minus t into sine 2t is equal to, you write now 4 s plus 1 total upon s plus 1 to the power 2 plus 4 to the whole power 2. Now you put this s plus 1 to the power 2 plus 4 to the whole power 2. This is a result of this function. I have solved this numerical. If you have any problem for this numerical, you comment for step first or second. In this type of numerical, 3 steps are arise. First I have solved to by partial of Laplace transformation sin t sin 2t. Now use a basic function of Laplace. This is a formula. Since I know that L sin at is equal to a total upon s square plus a square. Now simply second step is putting the value of e to the power t. Now I know that L e to the power minus at into ft is equal to s plus a. Now I have solved this. I am using this resultant of this. Now the step of third, I have used the resultant this. Now we know that I have also the conclusion of this of Laplace transformation by multiplication of t. L t to the power n into ft is equal to minus 1 to the power n d to the power n upon ds to the power n into fs. Now this result is used for this conclusion. So you solve this for this. Now this is a differential of this. You solve this differential, find the result of this. Now your answer. For divide of t. एग्जाम्पल फर्स्ट है आपके पास, फाइंड आउट द लाप्लास ऑफ साइन 2t अपॉन t. I have discussed in a previous lecture the multiplication of t, and now I discuss in this lecture division of t. Solution of this problem, we have L Sine 2t is equal to 2 upon s square plus 4 in a basic formula of Laplace transformation. Now you put the value of t, L sine 2t upon t is equal to integral s to infinite 2 upon s square plus 4 into ds. I have used some conclusion. L ft upon t is equal to integral 0 to infinite, no, s to infinite fs into ds. Now solve this integral. This integral is a basic of tan inverse. Now we have, you know that integration of dx upon x square plus a square is equal to 1 by a tan inverse x upon a. Now putting the value of this integral, now you write now L sine 2t upon t is equal to integration of this 2 into 1 by 2 tan inverse s upon 2 limit s to infinite. Now first put the limit infinite. 2 means cancel. First put the limit infinite. Tan inverse infinite. Now putting the value of s. This means tan inverse s by 2. Now solve this. L sine 2t upon t is equal to this value tan inverse infinite is equal to pi by 2. This is a infinite in a tan table. Value of infinite is equal to pi by 2. Now putting the value of this pi by 2 minus tan inverse s by 2. The solution of this function is this. Now second numerical for you can solve. Find the Laplace transformation of ft. Find the Laplace transformation of ft Laplace transformation of ft is equal to integral 0 to t sine at upon t into dt. Solution of this integral Laplace transformation. First you know that you solve. First step L sine at. L sine at is equal to a upon s square plus a square. Now divide up t. Next step. Next is L sine at upon t. Use the conclusion of previous classes. Otherwise use the conclusion of this. Now write this. Integration s to infinite a upon s square plus a square into ds. To solve this integral, This is a resultant of tan inverse. Now you put this a into 1 by a bracket tan inverse s upon a. Now limit s to infinite. Now you can write tan inverse, put the value of infinite, a is cancelled, infinite means tan infinite. Now tan inverse s by a. You solve this value is also pi by 2 minus tan inverse s by a. You can write this by inverse trigonometric function. You write now cot inverse s upon a. Cot inverse s upon a. Now again I have find the value of integral 0 to t. Now we know that the integral of Laplace 1 upon s fs is equal to L integral 0 to s 0 to s u fu du fu du fu du. We have I use this function. Now L integral 0 to t sin 80 upon t is equal to 1 by s cot inverse s upon a. S upon a. This is your answer. This is your answer. So you can note down this two numericals. First and second, this is very important function of Laplace transformation. Thank you.